All right, let's go ahead and do another problem. I'm just going to start by drawing the um, regular parent function. If I took away the 1/2 and the 2 and all the numbers here, I would have the parent function of f of x is equal to x cubed. And then that graph would look like 0, 0, 1, 1, 2, 8, and then -1, -1, -2, down 8, and then this graph is really hard to draw with this pen tablet. So it's really not supposed to look quite like that. A nicer, smoother graph would be more appropriate, but it's the best I can do. Anyway, that's the regular x cubed graph, and then now we're going to transform it. I have a -2 on the inside of the function, which means I'm going to go to the right 2. Remember, when you add or subtract numbers on the inside of your grouping symbols, or any symbol, your fraction bar, your radical symbol, your absolute value symbols, if it's on the inside, it's opposite movement of what you think it should have, so it's to the right 2. And then I have a number on the outside of my function, so that is going to compress my y values, and it's going to compress or stretch the y values. In this case, it's going to compress them. It's going to take my y value and half it. So let's go ahead and then move our graph. Our graph is going to be moved to the right 2. And I'll go ahead and put in my pretend xy axis. You will no longer be looking at the numbers on the old xy axis, and you will be pretending that this is now the xy axis. All right, so instead of going over 1 up 1, we're going to go over 1 and up half as much. Okay, so the y value gets compressed, and we're having that y value. And then instead of over 2 up 8, we're going to half that y value, and it's going to be over 2 up 1, 2, 3, 4. And then instead of back 1 down 1, we're going to go back 1 down a half. And instead of back 2 down 4, we're going back 2 down. Instead of going back 2 down 8, we're going to go back 2 down 4. And then we can go ahead and sketch our graph in. And then the red is actually the good function. So I'm going to get rid of the blue one here. And I'm not going to bother to erase the dashed lines, but there you go. Our y values were compressed. If the number is being multiplied on the outside, it's either going to compress or stretch the y value. So let's go ahead and do the next one. Oh, this has a lot going on. So if I get rid of absolutely everything, all the numbers and the signs, the plus or minus signs, I see somewhere buried in there is an x squared. And so that parent function looks like 0, 0, 1, 1, 2, 4, and then -1, 1, -2, 4, and there's our parent function. I'm just going to draw a sloppy sketch. Okay, so let's go ahead and figure out all the shifting we have. I have an up shift of 6. I have a right shift of 4. Remember, on the inside it's opposite. I am then also reflecting over the x-axis, and then I am compressing my y value here. So I'm just going to write the word flip, but it's flip over the x-axis, or reflect the x-axis, and then here, this number here is going to compress y. I usually don't write all this in. Maybe I should start. It's going to compress the y values. It's going to half them. All right, so let's go ahead and do our movement. We are to the right 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. My new xy axis is going to be here in blue. and ignore all the numbers on the old XY axis. You're now pretending that this is your new XY axis. And let's go ahead and graph this. Just hang on a second. Okay, so let's go ahead and graph this. Normally we would be over 1, down 1, but we are halving. Actually, normally we would be over 1, up 1, but we have to make our graph upside down so that it's reflected over the x-axis, and without any compression it would be over 1, down 1, but since we are compressing the y value, we're going to be over 1, down a half. And then instead of being over 2, down 4, we're going to be over 2 and down 2. So our y movement is half as much. So over 1, down a half, over 2, down half as much, which is 2. And then our graph is going to look something like this. Hopefully you do a better job with the pencil than I am with the pen tablet, and then I can get rid of this guy right here. And then that's what your graph should look like.